We can actually draw more classification evaluation metrics from the confusion metrics, such as the classification error. Classification error is a measure which is complement of the accuracy score. So that's 1 minus the accuracy score. And it's defined as the false positive and the false negative, which is the total number of error that we have made, divided by the total number of prediction that we have had. And in the other hand, we can define it as 1 minus the accuracy score, because it's a complement of the accuracy score. Classification error shows the percentage of incorrect prediction that we have had. So in our example, our email classification problem that we have had, we can compute the accuracy score as well as the classification error here. So we would have to sum up these errors that we have made, 2 plus 6, and then divide it by the total of prediction that we have had, or the number of emails, which is 450. So the error would be 6 plus 2 divided by 450, which is 2%. So our classification error is 2% and our accuracy is 98%. Another classification metrics that we can draw from the confusion matrix is called precision. Precision is the proportion of positive predictions that are correct. So these are all the positive prediction. This one is true prediction. That means that we have made the right or correct prediction. They are really positive. And this one is predicted as positive, but it's incorrect. So here, the formula for precision would be the true positive divided by false positive and true positive. If we go back to our example, our email classification example, we can find the precision. So the precision would be the proportion of positive predictions that are correct. These are all the positive predictions. Only 13 of them are correct. So that would be 13 divided by 6 plus 13, which is about 68%. There is another classification matrix that we can draw from the confusion matrix, and it's called recall or sensitivity, or the true positive rate, TPR. Recall or sensitivity corresponds to the proportion of positive data points that are correctly classified as positive with respect to all positive data points. So that means the recall or TPR is equal to true positive divided by true positive plus false negative. So if you want to see an example for our email classification problem, the recall here would be 13 divided by 13 plus 2, which is 87%. So the sensitivity or recall or the true positive rate for our example is 87%. So let's go back to our email classification problems, and we want to find the precision and recall and analyze it. So this is the confusion matrix. The formula for recall and precision is as follows. So precision is true positive divided by true positive and false positive. So we are working on the column. On the other hand, sensitivity is true positive divided by true positive and false negative. That means that we are working on the horizontal axis or x-axis. So let's go ahead and find precision and recall for this. Precision would be true positive 13 divided by true positive and false positive. So 13 divided by 13 and 6, which is 68%. So precision here is 68%. Recall is 13 divided by 13 plus 2. So we are going to work horizontally or on the x-axis. So that would be 13 divided by the total row here, which is 13 and 2, which is 87%. So the recall here is 87%. Precision recall trade-off. Because there is a relationship between precision and recall, so if you increase one, the other one would decrease and vice versa. So there is a trade-off. Let's see, go back to our example. Suppose we want to increase precision and which would lead to decreasing or lowering the recall. So our email classification problem, we computed the precision and recall using this formula. The precision was 68% and the recall was 87%. So if you want to, suppose we want to increase the precision to 100%. The way to do that is if we actually change our classifier here, this is the classifier line, if we change it so that we would have less false positive. That means that we have to, if we actually tilt it to the above, what's going to happen is we're going to get rid of these false positive points here. So if we get rid of these false positive points, then our precision would increase. So let's go ahead and tilt this classification line so it would increase our precision. But doing that would decrease our recall. So let's see. So we tilted our classifier line here, as you see here. So this means that we don't have any actually false positive. These are not false positive because they are below this line, so they are not in the false positive territory. So actually, if you look at all the data points here above that have been classified as positive, all of them actually have been predicted correctly. So this means that we have 100% precision if we compute precision here. This is the new table, the false positive, true negative, etc., etc. So if you compute the precision here, it would be using this formula. True positive is 7, divided by true positive plus false positive. It would be 7 divided by 7 plus 0, which is 100%. So we have 100% precision here. On the other hand, if we compute recall using this formula, it would be true positive, which is 7, divided by true positive plus false negative. So it would be 7 divided by 7 plus 8, which is 7 divided by 15. And that's 47%. So as you notice here, our precision increased compared to our previous setting, and the recall decreased. This is the trade-off that we will always face when we want to deal with the precision or recall. Increasing precision would result in decreasing recall, and increasing recall would result in decreasing precision. Because of the precision recall trade-off, if we want to increase recall, that would lead into lowering the precision. Let's go back to our email classification problem. So here, if we want to increase recall, what we need to do is to get rid of this false negative that we have here. This means we have to tilt this line, classification line, so that it would get rid of this false negative. So let's go ahead and do that, and then we're going to compute new precision and recalls. All right, as you see here, we do not have any incorrect prediction here. So that would lead to have 100% recall rate. But it would lead also to lowering the precision. So let's go ahead and find the new confusion matrix. According to these formulas right here, the new precision would be the true positive, which is 15 divided by true positive and false positive. So that would be 15 divided by 27 and 15, which is equal to 36%. So as you see here, our precision decreased. Let's now compute the recall. So recall would be true positive divided by true positive and false negative. So that would be 15 divided by 15 plus 0, and that's 100%. So we increased our recall, but at the expense of the precision. More about precision recall trade-off. So as we saw earlier, increasing precision would lead to decrease in recall, and increasing recall would result in decrease in precision. And that's called the trade-off between the two. So depending on the application, we must be careful what criteria to focus on. Should we focus more to increase precision, or should we focus more on recall and increase recall, which would lead to lowering the other one? The recall-oriented machine learning applications are those that the false negative error is costlier, such as information extraction in legal discovery or tumor detection, for example. A prediction model that would falsely predict someone would not have tumors is dangerous, because we would not let the patient know that he or she has cancer and needs to take care of themselves. So these are examples of recall-oriented machine learning application. Oftentimes in these applications, a human expert oversees the prediction process so that we would not compromise here. On the other hand, precision-oriented machine learning applications are those applications that false positive error would be costlier. For example, web search engine ranking or query suggestion or document classification. So for example, a web search engine doesn't want to or shouldn't actually make a false positive prediction. That's giving you a search result which is predicted positive to your query, but it's incorrect. It's like you're looking for a keyboard, but it gives you something that it's not related. So this is precision-oriented application. In this application, we want to increase precision, and it would be at the cost of recall. So when we want to use any of these metrics, you have to figure out, okay, is false negative costlier here, or is false positive costlier here? And depending on those scenarios, you have to see whether you should focus on increasing recall or increasing precision.